Okay, this is taken from the vectors revision tutorial. In this question, first and foremost given two lines, L1 and L2. L1 and L2. Let me check that I've copied up the equation of the two lines correctly. Minus 8, 8, 7 minus 2, 3, 2. Okay. So in this question, we are told that this line is refracted in the second line to give you a third line L3. So my L3 will be a line that's like this. L3. So our aim in this question is actually to find the line L3. So the steps that I'm going to do it is like this. So first and foremost, the step one is, in step one of my working, I want to find this point first. I call this point P. Find the point P. This is my first step, okay? I want to find the point P. The second step that I'm going to do is, I'm going to take a point on line L1. I call it A. I call this point A. Conveniently, the point on line L1 could be chosen as 3 minus 3, 6. Okay. In my step two, I will actually want to find the foot of perpendicular from the point A to the line L2. So I want to find this. I call this point F. Okay, I call this point F. So in my step two, my aim is to find step 2, right? My aim is to find the point F. And after finding the point F, the next thing I want to do is to find a point on L2, which I call Q. So step 3, right? Let me write here, step 3, I will find Q. Okay? So once I have done all those 3 steps, I'll be ready to find the line, step 4 again, find the line L3. Alright, so these are the steps I will take to find the line L3. So first and foremost, how do we go about finding the point P? P is the intersection between these two lines. So to find the intersection between 2 points, what we need to do is we have to equate the equation of these two lines. How do we equate the equation of these two lines? We will equate this to this and get the equation. Okay, maybe I should write in green. 3 plus 5 alpha is equals to 8 plus 3 beta. Let me check that green color is visible in my video. Yep, it's good. Then the next equation I have is minus 3 plus 10 alpha is equals to 7 plus 2 beta. And then 6 minus 8 alpha is equals to minus 2 beta. So to solve for the point P, I equate the two equations. And upon solving them, right, I will find that my alpha, if you solve these two, right, I will find that my alpha is equals to 1 and my beta is equals to 0. And then I can conclude that the point P which has a position vector OP will turn out to be 8, 7, minus 2. Incidentally, this point P happens to be the point given in the equation of line L2. So this is the first thing that I'll do. Alright? Then the next thing is I want to find the point F. Because this point F is on the line L2, I can actually start off by saying this, that the point OF has a position vector like this, 8 plus 3 beta, 2 beta, minus 2 beta. You have to bear in mind that because this point F is on the line L2, every point on the line, such as L2, every point on the line will have a position vector that looks like the equation of the line. Okay, with the point OF written or expressed in terms of beta, I can actually then write down the vector AF. AF. How do you find the vector AF? AF is actually OF minus OA. And what is OF minus OA? You take the vector OF in red color minus this OA. You take the subtraction, you're going to get 5 plus 3 beta, 10 plus 2 beta, and then you got minus 8 minus 2 beta. Right? Why do you think I want to find the vector AF? Okay, so it can't really see it. Let me just tilt a bit for let's see AF. Okay, can you see now? Okay. Alright, okay. So just now was not very visible. Now I tilted a bit. You can see better now. So I found my vector AF by taking OF minus OA. Why do I want to do this? This because if I know the vector AF, I know that the vector AF and this other vector 3, 2, minus 2. Where is 3, 2, minus 2? The vector 3, 2, minus 2 looks something like this. 3, 2, minus 2. Right, the vector AF and the vector 3, 2, minus 2 is actually 0. So what I'm going to do is, I'm going to take AF dot with 3, 2, minus 2 and equate to 0. And then I want to find my beta. Okay, so what you do is, you take this entire vector dot with 3, 2, minus 2 equal to 0 and you solve for your beta. Okay, if you were to dot product this, I'm going to do it on my calculator, okay? I'm going to do it on my calculator and calculate out the number. Let me be sure that I'll get right. So it's 15 plus 20. 15 plus 20. 15 plus 20 plus 16. 51. And then this one is 9 plus 4, 13, 17. So my beta, if you do arithmetic correctly, like what I did on the calculator, I got this is minus 3. Okay, so if my beta is minus 3, therefore that tells me that my vector OF will be equals to, if my beta is minus 3, right? I put minus 3 inside here. I'll get my OF as minus 1, 1. Okay, put minus 3 here. Minus 1 and 1. And then 6 plus 6 minus 2 is 4. Okay, so let me check again, okay? I put minus 3 inside here. 8 minus 9 is minus 1. Put minus 3 inside here. I get 7 minus 6 is 1. Minus 2 plus 6 is 4. So I get my vector OF from here. So having found the vector OF, I now want to find the vector, the point Q, or the position vector OQ. How do I find OQ? Because this point is midway between these two, I can say that OF is equals to OA plus OQ divided by 2. So from which I can find my vector OQ. How do I find my vector OQ? So I'm use my calculator again. Okay, it will be equals to 2 times, I think I don't write this. I'm going to write 2 of OF minus OA. And this will give me, okay, let me see that space. Okay, this will give me, okay, 2 times OF, so it's minus 2 times OF minus 2 minus 3 is minus 5. And then 2 times 2 minus 3 is 5. Okay, then 2 times OF again. 8 minus 6 is 2. So this is my OQ. So having found the point OQ, I am now ready to finish up to find the line L3 by doing this. L3 is R equals to a point on L3. The point on L3, the obvious choice will be the point P, which is 8, 7 minus 2. And then a multiple. And then to get the direction vector, right, I can take the vector PQ. You can also use QP, doesn't matter. So if you use the vector PQ, it will be OQ minus OP. OQ minus OP will be minus 13, minus 2, and then 4. So therefore, this is my equation of the line L3.